After understanding minus R effect of substituent on phenol, now it's a time to understand plus R effect. Plus R effect means loss of electrons by substituent during resonance. So those substituents which are going to lose electron during resonance on a phenol are said to be showing plus R effect. Let's check the example. This is phenol, and suppose this is another functional group I have added here as a substituent. Now two type of resonance are possible here. One will be from OH side, this functional group, normal resonance like this, and further movement will be there. One resonance is possible from this functional group also. How it will show a resonance? And obviously when OH group will show the resonance, let's show you. This will be the first movement. Now, will these electrons go toward this functional group? The answer is no. Oxygen do not have this capacity to absorb these electrons toward itself like nitro, because oxygen have four valence orbitals on it. 1, 2, 3, 4. If you will check the outermost electronic configuration of oxygen, you will find it have four valence orbitals on it. 2s and 2px, 2py and 2pz. Only 4 orbitals are there. These 4 orbitals it is using 1, 2, 3, 4, third for making bond with carbon, fourth for making bond with benzene. Fifth it can't make. If these electrons will come here for bond formation, it means fifth orbital will be generated. So fifth orbital is not possible around oxygen. So these electrons will not come to that side. They will go like this. Means normal resonance. So OCH3 is not affected by the resonance of OH like this. But when OCH3 will show a resonance, how? Same. Lone pair is there, deliver them. These pi electrons will go toward this carbon like this. Lone pair will come here. Double bond will come here. Single lone pair will left and oxygen will get a +1 charge. This will be the initial moment. Now you can check electrons are coming on this carbon to which OH is attached. Obviously these electrons will affect this OH group. Now in this condition, when OCH3 is donating electron due to resonance, we will say it is showing plus R effect. Now further movement will be this, like this. Obviously this oxygen cannot make bond with these lone pairs. This will be the next movement. Now again. OH as it is, and finally again here and pi electrons will shift back toward oxygen and final structure will be generated. Means OCH3 is showing plus R here. Due to resonance, the electron is delivered by it in a benzene ring. Now, from which position after plus R effect it can affect OH group? The answer is from ortho and para positions. Look, it was on ortho position and it has shown the resonance. The electrons are directly coming on the carbon to which OH is connected. You can check. So obviously these electrons will affect this OH somewhere. Check. Where? Obviously these electrons will affect the acidic nature of OH group. When I will solve all the cases, I will tell you how these electrons will affect the acidic nature of OH group. But you please check, when OCH3 is on ortho position, electrons are coming on this carbon to which OH is connected. Means plus R effect from ortho position is affecting OH group. Similarly, it will affect from para position. Check. Okay, let's draw it like this. Please check resonance from every side, like benzene ring like this and like this. Both type of benzene rings you will use for the testing of the resonance. I am using this benzene ring now, and OCH3 I am drawing on para position. So let's check. After plus R effect of the electron, plus R effect of the OCH3 group, electrons are coming on this carbon or not? Check. And whenever you will draw resonance, always you will make double-headed arrows. If I am forgetting, you please don't forget. Obviously, when oxygen will shift these lone pairs here, to double bond will come, and one electron it is completely transferring toward this carbon, so plus one charge will come, only one lone pair will left. These electrons here will come, these pi electrons will feel repulsion and they will move to that side on this carbon like this. Rest as it is, no change. Now these electrons will come in bonding and these pi electrons will feel repulsion and they will move to this carbon. You can check, electrons are coming on the carbon to which double bond will come here. Check. The electrons are coming onto the carbon on which OH group is attached. So definitely this OH group will be get affected by the plus R effect of the OCH3 group. The OCH3 group is showing plus R effect. Due to resonance, it is losing electron to benzene ring or it is donating electron to the benzene ring. And those electrons are coming on which position? To the carbon on which OH group is attached. So definitely this OH group will be affected by plus R effect of the OCH3 group from the para position. Now let's check from meta position. You please complete the resonance also. Further resonance will be like this. Complete it by yourself. Now let's check from meta position whether this plus R effect will affect OH group from meta position or not. Now I am drawing benzene ring like this. So with every direction you will try. So you will have not any confusion. Now check. OCH3 group is on a meta position. Let's show the resonance. Where pi electrons will move? That side obviously. Double bond will be here. Positive charge on oxygen. Reason we know why it is getting a positive charge. Because when it will transfer electron, one electron out of two, one electron will completely transfer toward carbon. Means it is losing its control on its one electron. So plus one charge. One electron it will keep with itself. Now this carbon is carrying -1 charge because one electron, this electron was of this carbon and this electron is completely transferred on this carbon, so -1 charge. This carbon is getting extra electron. Now further movement. Rest molecule as it is, no change. Now what will be the next movement? These electrons will come in bonding and these pi electrons will be pushed further. This one. So please check. The carbon on which OH group was attached, is it getting electron? No. It is not getting extra electrons. The electrons are passed away from it. Why? Because our OCH3 was present on a meta position. Means plus R effect of OCH3 from meta position is not going to affect OH group. If it is present on ortho position and para position, it is going to affect our OH group, but not from meta position. Means the conclusion is, in phenol, if substituent is showing plus R effect, plus R effect of substituent is going to affect OH group of phenol from ortho and para position, not from meta. This is the main point. Minus R effect was also getting operated from ortho and para position, not from meta position. Plus R effect of a substituent is also affecting OH group from ortho and para position, not from meta position. So the conclusion is, the final conclusion, if I say plus R and minus R effect of substituent on phenol will happen only from ortho and para positions, not from meta. Whereas plus I and minus I effects can be operated from any position, ortho, para, meta, doesn't matter. Only distance matters there. Please check plus I and minus I effect cases and plus R and minus R effect. Now, after knowledge of plus R minus R effect of the substituent, plus I and minus I effect of the substituent on a phenol, we can go for next acidic comparisons in phenol. So first have a command on plus R and minus R effect of the substituent and minus I and plus I effect of the substituent, and please check on what factors they depends. One more point, how to judge a substituent will show plus R effect or minus R effect. Look, on a benzene ring, if you are joining a substituent, like suppose I have joined AB substituent, the atom which is attached to benzene ring directly, like in this case, A is attached to benzene ring and this A is carrying lone pair. So obviously this lone pair, it will donate for resonance, means this group is going to show plus R effect. Whereas on a benzene ring, if you are adding any substituent, A is directly attached to the benzene ring and A do not have any lone pair, but it is connected with B, which is more electronegative than A. More electronegative than A. And both are connected with the help of pi electrons. So such groups always show minus R effect because they will absorb electrons from the benzene ring like this. Resonance electrons will come and they will absorb it like this. For example, if I say the substituent is cyanide, so will it donate electron or absorb electron during resonance? It will absorb electron. How we have judged it? Check. Carbon is directly connected to benzene ring. It do not have lone pair. It is connected with nitrogen, which is more electronegative than carbon, with the help of pi electrons. So definitely it will work as a substituent, which is going to show minus R effect. How? When resonance will come, electrons will come through resonance. So what will happen? It will absorb it like this. Double bond will generate between these two carbon and these pi electrons will be further shift. And after doing it, it will re-emit the electrons back to the benzene ring. Please draw the resonance. So cyanide group is going to show minus R effect. Whereas if I am using this group, functional group, amine, this one. So please check, will it show plus R effect or minus R effect? The nitrogen connected with benzene ring directly and it have a lone pair. So definitely it will show plus R effect. Means it is going to donate electrons to the benzene ring for the resonance. Once the resonance of OH will finish, the resonance of nitrogen will start. How? Like this. Like this. So when it will donate electrons, the nitrogen will carry +1 charge, means the group is going to show plus R effect. Donation of electron during resonance. That's it. First clarify these points and then we will go for next acidic comparisons of phenol. Thank you very much for watching the videos.